So today we are going to learn the basic concepts of the speed, time and distance. All we know is, we have learnt it in the school time. The basic formula is distance is equal to speed into time. We know that distance is equal to speed into time. Okay. Suppose there is a distance of 20 km per hour and time is equal to 4 hours. Then we know that how to calculate the distance. After 4 hours, how much distance has been covered, we know that how to calculate it. Distance is equal to speed into time. So speed is 20 km per hour, 20 into time is 4 hours. So 4 is equal to 80 km. So after 4 hours, that bike, that vehicle will have been covered the 80 kilometers. Because this is a simple formula we have learnt in the school time. Distance is equal to speed into time. That's why it came. We know this basic formula. At least we should know this formula. Then now let's see, there are the different cases in speed, time and distance. This is a very important formula. Please remember this formula. Distance is equal to speed into time. Okay. There is one case. We have to see the first case. First of all, we know that distance is equal to speed into time. Okay. Then if distance is constant, we have to take the distance as a constant. Okay. So if distance is constant, suppose I will take the distance as 80 km. Okay. We know that distance is equal to speed into time. Okay. We have to take here the distance constant. That's why I took here distance as 80 km and 80 km. Now if I take the speed as 40 km per hour, then we know that 40 2s are 80. Okay. And if I take here the speed as a 10 km per hour, this is the second case. This is the second scenario. This is the first scenario. In the first case we are seeing, we are learning the first case now, where the distance is constant. This is the first case. In that, distance is constant means distance is 80 km and speed is 40. So that speed is 40. That's why time will be 2 hours. 42s are 80, and here same 10 8s are 80. Okay. Distance is equal to speed into time. Now let's see from this what we have to come. What we know here, we know the basic formula distance equal to speed into time. So now let's see. Please observe it carefully. 42s are 80, 10 8s are 80. Okay. 10 1s are 10, 10 4s are 40. 2 1s are 2, 2 4s are 40. Okay. Observe carefully here. If distance is constant, then the ratio of speed and time. Observe carefully. Speed ratio is 4:1 and the time ratio is 1:4. 4:1, 1:4 means speed and time are inversely proportional to each other. Speed and time are inversely proportional to each other. From this, we came to know that if distance is constant, then speed is inversely proportional to time. We have proved here. Distance is constant. Then speed and time are inversely proportional. Speed is 4:1, so time is 1:4. This is the first case. Okay. Now let's see the second case. If time is constant, we have to take the time as constant here. So if I take the time as 4 hours and 4 hours, this is the first scenario, this is the second scenario. So, and if the speed is 20 and 40, then the distance will be, we know that distance is equal to speed into time. We just have to do the multiplication of these two terms. 4 2s are 80, 4 2s are 80 and 4 4s are 60. So let's see. If time is constant, 4 time is constant. The speed is 20 40, distance is 80 160. Then here 21s are 20, 22s are 40, 81s are 80, 82s are 160. So here observe here carefully. If the time is constant, 4:4, time is 4, sorry, this is not a ratio. Time is 4 in first scenario, and the second scenario also time is 4, means it is constant, time is constant. Then speed is 20 and 40, the distance will be 80 and 160, means if time is constant, speed and distance ratio is 1:2, 1:2. From this we came to know that if time is constant, then speed is directly proportional to distance. Speed is directly proportional to distance. We took here time as a constant 4 and distance speed is 20-40, then the distance will be 80-160. As the speed increases 20-40, distance will also increase 80-160. Means what? If the time is constant, then the speed and distance will be inversely proportional to each other. This is the second case. Now let's see the third case. Now we have to take here the speed as a constant term. If speed is constant, now let's see, if the speed is constant, then what will happen? Okay, we have to take here speed as a constant. So speed, if it is 40 and 40, in the first scenario it is 40, the second scenario it is also 40, and time, if time is equal 2 and 4, 2 hours and 4 hours, then the distance will be, we know that distance is equal to speed into time. We know that distance is equal to speed into time. So 42s are 80 and here 44s are 160. Observe here carefully also. Here speed is constant and time is 2 and 4. Distance will be 80 and 160. So we can take this term in terms of ratio also. 2 ones are 2, 2 2s are 4. 80 ones are 80, 82s are 160, 1:2, 1:2. From this we came to know that if speed is constant, then time and distance are inversely proportional to each other. So I can write here, if speed is constant, then time will be directly proportional to distance. Time will be directly proportional to distance. So the three important things we have seen here. The basic formula we learned in the school time. Distance is equal to speed into time. So if the distance is, we have to calculate if the distance, and speed and time, if it is given as a speed as a 20 km/h and time as a 4 hour, then we know that simply we have to multiply these two terms. So 20 into 40, answer is 80 km. The first case was there if distance is constant. Please listen it carefully because it is very important. All the problems are depend on this only on these three cases. So these three cases are very important. If you learn these three cases, then nothing is impossible in the speed, time and distance. You will get the problems quickly. The answers you can calculate very quickly. So please understand these three cases very carefully. If distance is constant, I have took here distance as a constant as 80 km, 80 km. This is the first scenario, this is the second scenario. Okay, 80, 80. If speed is 4, 40, then the time will be 2. And if speed is 10, then the time will be 8. So 42 are 80, 10 8s are 80. So if the distance is constant, then I took in terms of ratio. 10 1s are 10, 10 4s are 40, 2 1s are 2, 2 4s are 8. So if the distance is constant, then speed is inversely proportional to time. Speed is inversely proportional to time. If time is constant, so we have to take the time as a constant here. So time is 4, then I took here speed as a 20, 40. So the distance will be 80 and 160. So I can say here 21s are 20, 22s are 40, 81s are 80, 82s are 60, 1:2, 1:2. So it is proven here. We have proved here that if the time is constant, then the speed and distance 1:2, 1:2 means they are directly proportional. So this is the second case. If time is constant, then speed is directly proportional to distance. And the last case is if speed is constant. So I have taken here the speed as a constant as a 40. I took here time as a 2 and 4, and distance will be 42s are 80, 44s are 160. So 2 1s are 2, 2 2s are 4, 81s are 80, 82s are 60. I have taken here in terms of ratio, that's why I divided these terms. So 1:2, 1:2. So from this we can say that if speed is constant, then time will be directly proportional to distance. If speed is constant, then time is directly proportional to distance. This is the third case. Only these three cases are there in speed, time and distance. So this is what we have learned. These three cases are there. you can stop the video and can put it down on the paper also. If distance is constant, then speed is inversely proportional to time. If speed increases, then the time will decrease. Okay, how it came, we have know that, we have proved that. So no need to tell you again. If speed is x is to y, then the time will be y is to x. If speed is constant, then time will be directly proportional to distance. I mean, if the speed is constant, then if the time increases, then the distance will also increase. So if time is x is to y, then the distance will be x is to y. If time is constant, then if the speed increases in the constant time, then the distance will also increase. So if speed is x is to y, then the distance will be also x is to y. So you can put it down on the paper. Thank you.